Welcome back, algebra students, to another day of chapter 11. This is 11.7. We're moving on in chapter 11. We spent 5 days learning about radicals. We learned about how to simplify radicals. We learned about how to get radicals out of the denominator. And today, and I guess it would be Friday, we're going to talk about adding, subtracting, and ultimately multiplying radicals. So there's just 2 days. This is day 1, adding and subtracting, and Monday will be day 2. And so our essential question is, can I add and subtract radicals? Which I'm hoping sounds kind of easy, because once we really figure out what it's asking us to do by adding and subtracting radicals, if you can simplify radicals and add and subtract numbers, you're good to go. So here's one thing you need to know. We need to know about like terms. And you've probably seen that before. In fact, I'll get like a little post-it note here. Let me do a little example. If I had 2 x's and I added it to 3 x's, these x's are like terms. We think of them as like apples. 2 apples plus 3 apples is 5 apples. These are not like terms. If I have 2 apples and 3 oranges, you can't say 5 what? Like, those are not comparable. You cannot add up unlike terms. So you can only add up like terms. If they're not alike, you cannot add them up. So when we have like terms like radicals, the square root of 2 and the square root of 2 are like terms. For example, square root of 2 plus the square root of 2 is 2 roots of 2. So if I have 1 apple and 1 apple, I get 2 apples. Or if I have another example, 3 roots of 3 plus a root of 3, which is technically 1, there's like an invisible 1 there, that's 4 roots of 3. So that's our really big takeaway. Right away, we want to make sure that we're doing this every single time. And I just have a few examples that use that information. So let's look at one example right away. That's not what I have here. 7 roots of 2 plus 3 roots of 2. So you first determine, are they like terms? Can I combine them? And yes, they are. We have like terms here, square root of 2 and square root of 2. And if I have 7 roots of 2 and 3 roots of 2, what do I have? I have 10 roots of 2. And you ask yourself, as it's simplified, is the radical simplified? Yes, there's no perfect square. Can I simplify 10? Nope. So I know that that is my answer. And again, when we're adding, we want to look for like terms. Let's look at a problem like this. And again, if I'm going kind of fast, feel free to pause after each problem. 3 roots of 2 and 3 roots of 3. Let's simplify that. Are there any like terms that I can circle and combine? There is not. The square root of 2 and the square root of 3, I cannot combine. I have 3 apples and 3 oranges. I can't combine those and say I have 6 something. So that is the simplest version. Like, that's my final answer. I can't simplify it any farther. Now let's look at an example like this. The square root of 12 plus the square root of 27, and I've intentionally kind of separated those out a little bit. Because when we're looking at this, you might say to yourself, well, there's no, 12 and 27 are not like terms. I can't combine those. But they are not simplified. So kind of step 1 is to simplify the radical if possible. If you need to. Up here we didn't need to. Square root of 2 is, you can't simplify it any farther. Square root of 3, oh, that's over here. Can't do anything. But the square root of 12, I can simplify. So I'm going to use a different color to quickly do that. What perfect square goes into 12? And you could write them out here. 2 times 2, 3 times 3, 4 times 4. 4 does, and 4 goes in 3 times. So the square root of 4 times the square root of 3 is the square root of 12. And we picked 4 because that turns into a whole number. So we're good there. I simplified the square root of 12. We did that a few days ago. And I'm going to add it to the square root of 27, which is also not simplified. So let's simplify that. What perfect square goes into the square root of 27? 9 and 3. Well, 9 is the perfect square that goes in. It goes in 3 times. And I like those perfect squares because the square root of 9 is 3. Hey, guess what? I can combine it. So you simplify it, and then you determine, can I combine it? And in this case, you can, because, oh, where was that color that I used? When you find your like terms, like a 3 and a 3, square root of 3, square root of 3, well, I have 2 apples and 3 apples because they're the same. So your final answer is 5 apples, or 5 roots of 3.